Good people. Question 8. We're still on that paper, June 2024, Eastern Cape. 8.1. Now, 8.1, it's saying show that x minus 2 is a factor. So how do we show that x minus 2 is a factor? Remember, solving this is just x is equals to 2. So we're going to take 2 as positive, putting here, if you get 0, therefore x minus 2 is a factor. So x into 2 is equals to negative into 2, then cubed, sorry, here, and then plus 12 into 2, and then minus 16. You punch your calculator. I hope you did get the answer of 0. Then from therefore, after getting that 0, you do say that x minus 2 is a factor. Please, at the end of the day, writes the explanation or the conclusion. This was 8.1. Now, 8.1.2, they're saying find the x-intercept. Remember, if we are finding the x-intercept, first we let y is equals to 0. So we're having 0 is equals to, we're going to have negative x squared, x cubed, and then plus x squared 0. It's very important that I'm going to put this because it's going to help me a lot. Then plus x squared minus 16. As much as you don't see it's there, but it's going to help me during the factorization of everything here. Now, remember, I've already given me a factor that my factor is x minus 2. This is a factor that I have. Whatever that is left is the one that is the second bracket here. Now, remember, to find the last term here, you take this here, and then you say 16, negative 16 divided by this negative 2, you're going to get positive 8. So the term here is going to be positive 8. Now, for me to get this negative x cubed, you must times it with negative x squared. Now, I don't know the value here, but the value that is going to be here, it's going to be x. Whatever value that's going to be here, it's going to be that value of b that has an x next to it. So I need to find this coefficient of b. How do I find this coefficient of b? I say this times this, which give me what? Positive, which is going to be positive x squared. Now, this and this, it's going to give me another b x squared equals to, this is squared, sorry guys, equals to, coming here now, coming here, this is gonna make a difference now. It's gonna be 0x squared. If you don't have anything that has a squared, it's there, just that it's 0. So equals to 0x squared. Remember, I'm solving for OP, so I'm gonna take this to the other side. So it's gonna be bx squared equals to, change its sign, is negative 2x squared. Now remember, I'm solving for OP, so divide by x squared, divide by x squared. So my b is what? Is negative 2. So I know here it's what? It's negative 2. Now let me cancel whatever that I have here. Putting my b also here, that is negative 2. So I know this is negative 2. So from here, I know this is 0 is equals to x minus 2 into negative x squared minus 2x and then plus 8. Now I'm going to have to factorize this that I have here. It's going to be 0 into x minus 2 into, this is going to be x and negative x. Remember, this and this is to give me this. Then I'm going to have negative 4, and then I'm going to have negative 2. Because timesing this and this has to give me this, and then this and this has to give me this, taking a factor that we're having a negative x there. Now the fact's value is going to be, or x is equals to 2, or here another x is equals to 2, or another x here, which is going to be x is equals to negative 4. Take into consideration, guys, that I'm having negative x and negative x here. So this is gonna go to other side and become positive, but I'm solving for x, then I'm gonna times it with negative or divide with the negative and then become this x become negative 4. I hope everything understand that part now. Now going to question 8.1.3 is saying determine the coordinates of the turning point F. Now the turning point, remember, in order for me to find the turning point, first thing I must do my derivative. So the derivative of that function is going to be negative 3x squared plus 12. Turning point, we let our derivative is equals to 0. And then from here, we solve for x. So it's negative 3x squared plus 12 is equals to 0. This on the other side. So it's 3 squared is equals to negative 12. Then divide by this negative 3, divide by this negative 3. So my x squared is equals to 4. It's either you take this to the other side, you do the dots, or you just square both sides. The dots is the difference of two squares, guys. So x is equals to plus or minus 2. So my first x, after that, guys, okay, let me just say my first x is equals to 2 and my another x is equals to negative 2. Then from there, you take this value of x, you put it right here to find my y value. So my y value, if I take these 2 and put it there, is going to be 0. Remember, I already find it that x where x is 2 and then it's going to be 0 there. Then taking the negative, now when I take this negative and then I put it there, and then my value of y, it's going to be negative 32. So the turning point, it's going to be x, or x is 2 into 0, and my another one is going to be negative 2 into negative 32. I hope everyone understand that part is very, very important. Now let's go and draw our graph. People, now we are drawing our graph of this function that we have given here, which is our cubic graph. I've already drawn my points. This is x into negative 4, which is my x-intercept. This is my x into negative 2. Now, this one is very, very careful. This x negative 2 goes with this turning point here, which is mapped to negative 32. This is 32 here, and then here this point is my y-intercept, which is negative 16, where the whole point is 0 mapped to negative 16. And then here I'm also having this as an x-intercept, but also as what, as a turning point. Now let me draw my graph. So it's gonna goes from here. So it goes from here, coming here, beg my pardon, guys, coming here, and then it turns here, then it goes to 16. I'm sorry, guys, for not the accuracy, but I'm trying. So, and then coming here, and then from here, it turns downward, then coming downward like this. This is more or less the shape of the graph that you have to grow when we are doing this question then. Now, let's go to 8.1.5. Now, they are saying, let's find the equation of a tangent. The equation of a tangent at the point of the inflection. Very important at the point of the inflection. So that's where you need to start, at the inflection point. How do we find an inflection point? Let's first start by doing the first derivative. First derivative, it's negative 3x squared plus 12. And then from here, remember, we're talking about the inflection. So do a second derivative. Do the second derivative, which is negative 6x. Then remember, the second derivative is going to be equals to 0. And then it's going to be 0 is equals to 6x. Then we divide by 6, divide by 6. Then my x is going to be 0. Now remember, I have to find a point. So I'm taking this 0 here, putting on the original equation, and then my y is going to be what? It's going to be a negative 16. Now the point of the inflection point now, it's 0 maps to a negative 16. Now this tangent that I'm talking about here is going to be crossing this point of the inflection. Now, let's find the gradient. How do you find the gradient? Remember, finding the gradient, you must do the first derivative of what? Of the equation that we have here. What is the first derivative that we have? First derivative is equals to 3x squared plus 12. And then from here, remember, we're talking about the point of inflection, substituting our x. So it's going to be negative 3 into 0 squared and then plus 12. Remember, the derivative is what? Is the gradient. So the gradient is equals to, this is just what? Is just 12. Then from here, I do have a gradient. Now I say y is equals to mx plus c. I need to find my c. I do have the point, which is this one. My point is negative 16 is equals to 12 as a gradient. I know my x is what? Is 0. So it's 0 and then plus c. Then my 16 is what? Is negative 16 is equals to c. So y as an equation now, which is the straight line, which is the equation of a tangent. So it's y is equals to, my gradient is 12x. Then my c, it's negative 16. Now, this is the equation of the tangent that is passing a point of the inflection. Now, let me go to my second part of this question 8.